You're going to have to pardon me because this is the first time I've actually used the drawing tablet as a communication tool for making lessons. So I'm hoping that it works out nicely and you can understand my writing. So as you can see here, I've written at the top here that these are resistors that are placed in series. And I know my handwriting is awful. I'm going to get better at this. I'm also going to learn how to place type over top of the drawing so that it's easier for you to understand. But for now, I'm just going to go over the basic concepts of a circuit where resistors are placed in series and how to calculate total resistance values in these circuits. So on the left-hand side here is a pictorial diagram of a circuit, which means that somebody's tried to be fairly realistic in drawing the conductive pathway. So for the power source, they've made a Duracell battery. I just want you to know that I'm not receiving any money from Duracell for this commercial. I tried to sell the rights to Energizer, but they were not interested, so Duracell battery it is. And then I've got a couple of resistors over here that look very much like real resistors. These look to have a silver tolerance band, 3 value bands. We could figure out the numeric value of these resistors, but we're not going to right now. We're just going to arbitrarily assign some. But this is pretty much how the circuit would look if you built it. And there'd be no indication that the circuit was on. Just what would happen is these resistors would limit the flow of electrons between the negative and positive pole of the battery. And they'd get a little warm, and they would continue to be warm until such time as the battery was depleted, which would take a short time or a long time, depending on the value of the resistors. So this is actually just a theoretical circuit. Doesn't do anything. Over on the right-hand side, we have a more traditional type of electronics diagram that describes the same circuit. It's called a schematic diagram. And in schematic diagrams, every electronic component that we use has a picture that represents it. So instead of the Duracell battery, we just have this symbol here indicating a direct current power source. So the positive lead of the battery is shown by the longer line and the negative lead by the shorter line. And there's the conductive pathway indicated here by wires. I don't know why there's a break in the wire here. We'll see if my pen skills are good enough to fix it. Oh, close enough. There we go. So this would be now a complete circuit. And then over here we have 2 resistors. The schematic diagram for a resistor is basically a conductive pathway, so like a wire line, but it's made longer by making it a zigzag, which effectively, if you took a wire and you made it longer, the resistance would increase. So that explains why this is part of the system diagram, or sorry, the schematic diagram for this particular circuit, which just has 2 resistors placed in series, which means that electrons being conducted through the circuit traveling from the, and if you recall, they go from the negative to the positive pole of the battery. Not that it matters, but that's the real way. The general public believes that electrons travel from the positive to negative, and we'll just let them. So these resistors, we're going to give them arbitrary values. We'll call resistor 1 here, we'll say this is 10 ohms. And resistor 2, we'll say this is a 20 ohm resistor. Now, calculating total resistance in a circuit is really easy. So the formula here is T equals R1 plus R2. Simple enough, right? There's 2 resistors in the circuit. They're placed in series. So R1 is 10 ohms, R2 is 20 ohms, so R total equals 30 ohms. If there were 5 resistors in the circuit, all placed in series, we would simply calculate them as RT equals R1 plus R2 plus R3 plus R4 plus R5. Super simple. So that's it. That encapsulates resistors in series. It is very easy to calculate their values. All you have to do is add them. Just as a caveat, all of the values that I've given you so far are in the base unit of ohms. I haven't given you any that are in, say, milli or micro ohms or mega or kilo ohms or anything like that. If they are in different prefixes, different metric prefixes, you'd have to calculate them all in the same. So if you put them all in kilo ohms, it'll work. If you put them all in ohms, it'll work. Just it's easiest if they're all in the base unit. So that's what I've been kind of concentrating on. Okay, that concludes resistors in series. View this, view the one in parallel, and you'll have an easier time with your homework.